Hi, in this video I'll answer a couple of problems that ask us to find the rate of change of some quantity. So the first question says, suppose in a right circular cone of base radius r centimeters and height 3 centimeters that r is increasing at a rate of 4 centimeters per second. Find the rate of increase of the volume of the cone when it has radius 10 centimeters. Well, we can draw a quick diagram of the cone. It has height 3, it has radius r, and r is increasing, so the cone is getting wider, which means the volume is also increasing. Now, the first thing to do is to assign variable names to any quantities that don't have them. So we'll let b equal the volume of the cone. And next thing is to write down any information or formulas that we have. So we have that dr dt equals 4. That's the rate of increase of the radius. And also the formula for the volume of a cone is 1/3 times pi r squared h. And h is 3 in our case, so that just becomes pi r squared. Alright, we're asked to find the rate of increase or the rate of change of the volume. So that means we're looking for dv dt. Now, v is a function of r. If it was a function of t, instead we could just differentiate and get our answer, but instead we'll have to use the chain rule. The chain rule tells us that dv dt equals dv dr times dr dt, and we have dr dt, that's 4, and dv dr we can obtain by differentiating our volume formula. So if we do that, we get 2 pi r times 4 for dr dt, and that equals 8 pi r. Okay, now we need this value when the radius is 10, so when r equals 10, dv dt equals 8 pi times 10, which equals 80 pi, and the units are cubic centimeters per second. One quick comment about the chain rule. You can think in terms of being able to cancel the differentials here, dv, dr and dt. So we have a dr here that we can cancel with the dr down here, and that leaves us with dv over dt, which is the same as what we have on the left hand side. And with chain rule equations, that should always be the case, that when you cancel out you get the same expression on both sides. Okay, we'll have a look at the second problem now. And it says, suppose air is filling a spherical balloon at a rate of 5 cubic centimeters per second. What is the rate of increase of the surface area when the balloon has radius 20 centimeters? Okay, we'll draw a quick diagram of the balloon. It has radius, we'll say the radius is r. Now we're given that the balloon is increasing in volume at a steady rate, so that means the sphere is getting bigger, and that means the surface area is also increasing. So we'll assign some variable names now. We'll let r equal the radius, v equal the volume, and a equal the area. Okay, we're given that the volume is increasing at a rate of 5, so we have dV dt equals 5. We also know the formulas for the volume and area of a sphere. Volume is 4/3 times pi r cubed, and the area equals 4 pi r squared. And we're asked to find the rate of increase, or the rate of change, of the surface area. So that means we're looking for dA dt. And again, we don't have A as a function of t, so we have to use the chain rule again. And we could easily obtain dA dr by differentiation with the area formula. So we'd expect to be able to use dA dr here. And we're also given dV dt, and since there's also a dt down here, we'd expect it to appear here also. Now we need a dr here to cancel the dr down here, and a dV here to cancel the dV up there. Now dr dV, well, we have V as a function of r, so we could find dV dr fairly easily, and that's just the reciprocal of dr dV. So actually we could write this expression this way: dA dr divided by dV dr times dV dt. Okay, we'll differentiate our formula now and substitute in. So dA dr is 8 pi r, and dV dr is 4 pi r squared, and multiply that by dV dt, which is 5. Now we do some cancelling here. We're left with a 2 times 5 is 10, and an r in the denominator. Alright, we need this quantity when the radius is 20. So when r equals 20, dA dt equals 10 on 20, which equals a half, and the units are squared centimetres per second. And that's our answer. Okay, well, if you have any questions or comments, please leave a comment below, and thanks for watching.